Hi all, let's make a start. Today I'm going to cover 7C and 7D. 7C is just reviewing the sum, addition and of ordinates for the sum and difference of functions. We look at some of the properties of product of functions, and well, 7D will look at some function notations and its application for you to do some algebraic resolution. All right, with sum, difference, and product. So you have the notation for how you do the operations of those functions. What's going to be critical when you start with is determining the domain of the resulting function. So for the sum and the difference, the resulting function, which is here and there, the domain will be the intersection of the domains of each function. So very important. So here, for example, let's say I have a linear function x, the domain is R, and G, I make it a restrictive domain, so a function like square root of x. The domain for G will be 0 to positive infinity. If I do the intersection of the domain, it will be just the domain of G, which is 0 to positive infinity. So the domain will be of domain for the sum, the difference, and the same for the product will be restricted with the smaller domain that is common to all functions. Okay, so you can use a set notation, you can use a number line, whichever works for you. With a few strategies that you will need when you want to graph those. So let's look. Go back. Okay, so this nothing new here. When you have a you use the addition of ordinates. If you have a sum of a function, if one of the function is equal 0, the sum will be equal to the other function. If they're both positive and one and the sum of the function will be always greater than the highest, and if they both functions are negative, the sum of the function will be under the lowest function. If they change sign, so they either positive or negative, the sum of the two is going to be between f, which is the positive, and g, which is the negative. Also look for when the functions cancel out. So if you add those two, that will give you the an x-intercept. Alright, so that's it for 7C. Have a look and the working out of the work examples, and let's move on to 7D. So function notations and identities, which is linked to proofing. This is the log rule, so you have log of e of x plus log of e of y equals log of e of x y, the product. Now if we define the function f of x being log of e of x, if I substitute x here by y, I will have f of y here. So the first one is f of x, the second one we substitute y, that gives you f of y, and similarly if we substitute xy in here on the left and the right, we also have f of the product xy. So this is a way to summarize one of the properties, for example, for the log rule. We do that, let's say, with an exponential, and we're going to come up with the function notation. So here, exponential of the difference of the powers gives you a quotient when you expand the exponential. That's from your index notation. So if we define that function accordingly, we can summarize this. F of the difference of the variable is going to be equal to the quotient of the variable. So here are some of the applications we use as kind of notation. We define a function, and important here is you need to show. Okay, now in order to show that they actually not equal, what you can do is do it on two columns. Do the left hand side by using the definition of the function. Do the same on the right hand side. So we do f of x plus y on here, and we simplify. We do the right f of x plus f of y. We simplify the expression, and now as we can see, they're different, and we need to write a statement saying that those expressions are not equal. Then you can conclude. So the order of the sequence matters. Okay, first you compare the statements, you write it out that you observe that they are different. Then, because those expressions represent their original respective functions, then you can conclude that your original function f of x plus y and f of x plus f of y are not equal. Okay, so very simple example, that the structure of the working out is something you need to model. Okay, so there's a few more examples for you to go through. So it's just for you to get used to this kind of notation. And that's all we have for 7D. See you later.